Today we are going to learn about basic of simulation on NX12. For this we will see a simple example that how to set up a 3D model and learn simulation step by step. Please don't skip and watch full video to learn how to simulate on NX12. So welcome to AB Design Studio. I hope you will like it. Let's start this tutorial. In this tutorial you will learn in two steps. Step 1 is the create a 3D model and step 2 is simulate a 3D model. Go to sketch, select a front plane and OK. We have to draw a lines by select a profile toolbar from a direct sketch toolbar. So draw from center line. We have to draw a two lines. First, here we will see a simple example. So roughly we create a 2D geometry from in which we create 3D model. So after create a 2D sketch, we have to constrain this by defined dimensions. So here we have to put this as a 50. We take both lines 50 mm. Our next step is to create a fillet. Here you can say sketch is fully constrained. So select a fillet tool. Select line 1, line 2. Now putting a radius as a 5 mm. Okay. Next step is select offset tool bar. Here is the offset curve. Select 2D geometry in which we can offset. The direction is a outward, so we reverse this direction as a inward. Distance is 2 mm. Okay. Now select a line toolbar for close this 2 point. Okay, we have to close this 2 point. Our 2D geometry is finished. So we have to finish this sketch. So select a finish sketch. Now our 2D geometry is fully completed. We have to now extrude for to generate a 3D model. So select a extrude tool from a 3D toolbar. Here we have here is a section, direction and boolean and other options. First we have to select a section curve. Here we have to extrude. You can either this direction or this direction, but we have to choose in both directions. So change this from value to symmetric value. Put this 10 mm is little bit slow, so we have to put 20 mm. Okay, our model is now extruded. Now we have to remove this sharp edge in 4 sides. So we have to create a fillet in So you have to choose a edge blend from features toolbar. Select edge blend. Here is the window open. We have to choose 4 side. Okay, this one and this one. Okay, radius is defined 20 mm. Our 3D model is now created. For a better result, we have to create slots in which we getting better results after simulate. So to select planes and sketch a slot. After that we created. Again go to sketch, select plane, okay. To create a slot, choose a rectangle tool from a sketch toolbar. Select a rectangle tool. There is a 3 method to create a rectangle. First one is 2 point, second one is 3 point, and third one is from center. Here we can choose from center. So let's find a middle point in which we can create a rectangle here. Let's select midpoint and define width, put 20, define height 5, and angle is 90. Okay, our rectangle is now created. Again our next step is to create a arc here. We can simply create a arc by arc toolbar, arc tool through 3 points, or by center and end points. We have to choose any of these 2 methods. Select arc tool, arc by 3 points, by center and end points. To choose arc by center and end points, select midpoint and end points. Our arc is now created. Again repeat this process. Midpoint, end points. Okay, our slot geometry is ready, but here we will check the geometry is fully constrained or not. There is a 2 auto dimension. Define 2 auto dimension. We have to change this as a driven. Okay, and also sketch is now fully constrained, but here we can also change the both lines, convert to a reference. Yes, select lines, then convert to reference. Okay, select line, convert to reference. Sketch is fully constrained. Finish sketch. Our first slot is ready. Next go to sketch for second slot, select plane. Okay, again repeat this. Select rectangle tool from center, find midpoint. Okay, define width, define height and angle, then okay. Our rectangle is ready. Again we have to define arc, Arc by center and endpoints. Select midpoints, endpoints. Then we have to repeat this process. Select midpoint. Okay. And endpoints. Our arc now complete. Here also two auto dimensions. We have to change this to convert to driving. Also this convert to a driving, and also lines convert to reference. Line select, convert to reference. Now sketch is fully constrained. Finish this sketch. Two geometry are now created. After that we have to choose, select extrude from features toolbar. We have to select a section curve, define direction, to reverse this direction, and value is until next. Then boolean operation, we have to select subtract, then okay. Slot is cut. Process next sketch, also reverse this direction, and value is now until next. So boolean is subtract, okay. Our model, 3D model, is now successfully created. Now we have to save this model. For save, select a file, save as. Again we have to create a new folder, name this simulation tutorial. And name this chapter 1 _ chapter 1. Now okay, our 3D model is now saved. Our first process or step is completed, and we have to now go to second step. Second step is simulate this model. To simulate this model, we have to go to simulation module. For this we have to select application. There is a different application here: design, manufacturing, simulation. In simulation there are 4 types of simulation: pre-post, flexible pipe, motion, and design. Here you can see this simulation application. In this design module, design analysis, select design. There is a window open, new FEM and simulation. FEM means finite element method. Let's see, here is a solver, environment is solver, NX12 design, analysis type structural and thermal. Here we learn about structural analysis, so we select analysis type as a structural. In my next video I will explain about thermal analysis or see a simple example. our next window is solution window. We have to set up solution. We have to change this name from solution to test model 1. By default, our solver is NX master and analysis type also. Here we select structural analysis type. Solution type is linear, static, single constraint. There is also a different option. We can see here displacement, stress listing, strain listing. In my next video, we talk about in this topic. Okay. Now you can see the simulation toolbar. There is a 4 step. Step 1 is sign materials. Step 2 is mass. Step 3 is constraint type. Step 4 is load type. After this, we get results. But before getting results, we have to solve this model or problem. So let's start. First, we have to assign a material. Here is a library of materials. There is a many materials which we can use. We can use any of metal category. We choose metal category. So there are different metals here. First, we can choose steel. We can select any of this steel because we have to simulate a metal. So we have to choose here AI SI 310 stainless steel. Material type is isotropic. Here you can change orthotropic, anisotropic or fluid. But we have to select by default isotropic. Okay, our material is now assigned. Next is to mass. Here we choose a 3D tetrahedral. Creates a mesh of 4 and 10 node type. There we have to first select a body again, and after that we have to select element properties. See tetra 4 and 10. We have to select here C tetra 10 and mesh parameter element size. You can change here, but now this time for beginners we have not to change this. 1 mm is perfect. Easily we get answer, we get results. So 1 mm is fixed. Mesh quality option. There is a mid-node method, mixed, curved or linear. We select mixed. Again in mesh setting, there is all are by default standard settings. For beginners, nothing you have to change. Nothing is now start. You can see here work in progress. Okay, look at this. Our meshing model, how it look like. It's a beauty meshing look. You are seeing this model in NX12. There is a beauty. You can see here a tetrahedral mesh profile. Our next step is to constrain this model by applying fixed constraint. Any of this side we have to fix, so select a fixed constraint. There are many more constraints here, but we have to select only fixed constraint by click any of the side. You can see a blue lines generated here. These are the constraints, fixed constraints you can see here. Our next is to load type. We have to now apply a load. There are different type of load: bearing load, force load, torque, pressure, hydrostatic pressure, centrifugal pressure, gravity, rotation, temperature load. But now we have to select only force, created force load, so I have to choose force. Here is the force window is created. We have to select then create a force. We have to put some value. There is a 1 Newton. Okay, next is the direction. Choose a vector. This show the board, but we have to apply load in downward direction. So reverse this. Now apply. Yeah, what a beauty! You can see this, the red arrow in downward direction, so the uniform distributed load. What a beauty! You can see just after that. Our fourth step is also completed. Next process is just solve this model to getting results. Here is the solution toolbar. You have to select solve, analysis, job monitor, or solution. Already we have to create a solution, so we have to now only select solve and solution. See, a solve window is open. We have to click only OK. Okay, you can see here our solver is now started. Now we have to wait some time to getting results. You can see here the information, analysis of monitor, it shows in progress, and third one is the solution monitor. Here you can see the progress. Okay, wait for some time and to get results. You can see here our solver is now completed. Solution is ready to see. Okay, close all the window. Close here. Here see completed chapter 1, simulation 1, test model. Cancel this and close this. Now we have to see, finally we have to see the results. You can see the results now. Okay, drop down plus structural, you have to select structural, click right click, open. Please wait for operation to complete. Okay, work in progress. Wait for some time. Now ready to see the results of our work. You have to work here. There is a displacement. You have to double click in displacement or magnet. Yeah, we can see the results of displacement. We can see the red area with the larger displacement here, maximum displacement in this section. Then you can also animate this model to see how this will displacement throughout. Okay, stop this. Now we have to results. There is a minimum and maximum is 0.0034 mm. All this window is a solution window. You can see here from 0 to 0.334. You can see this. I hope you will like it. Thank you for watching.